going to start with a very basic piecewise function, all horizontal lines. The first function here is f of x equals 2. That is a straight, flat, horizontal line at 2. We're going to graph this for all x values less than or equal to 1. So we're going to start on the negative side of the graph all the way until we get to x equals 1. And then we're going to jump down to negative 3. So from 1 to 3, x equals 1 to x equals 3, we are the horizontal line negative 3. And then at x equals 3, we jump up to 4, and we continue that for the rest of the graph. The last thing you need to worry about here are your end points. Should they be open circles or closed circles? You use closed dots every time you see a less than or equal to or a greater than or equal to, and you use open circles every time you have a less than symbol or a greater than symbol. So this line will have a closed dot. So it will be 2 all the way up until we get to 1 and end with a closed dot. Move down to negative 3, open circle until we get to x equals 3, open circle. Jump up to 4, and this would be a closed dot. And there's our graph. Let's do a more interesting problem. So for this one, it helps me to kind of pick out my starting point. So let's deal with this first equation here. This is for x is less than negative 2. What is our value here if we sub in a negative 2? Okay, at negative 2, our value is 3. And we need to have an open circle because this is just a less than symbol. It doesn't have the line underneath it. Now I am going to use my slope here, rise over run, to come up with my second point. So remember, rise over run, usually rise tells you how far up or down to go, and run tells you how far forward to go. So this slope, that is our slope, our m value. This slope is 1/2. So to get from this point to the next one to the right, we would go up 1 and forward 2. But this graph is just defined for x is less than negative 2, or x is more negative than negative 2, or x is to the left of negative 2 on your graph. So instead of going up and forward, we need to go double negative, down and backwards to get to our second point, because this graph is only defined here on our negative values all the way up until we get to negative 2. So we are still using the same techniques, rise over run, to graph. Just pay attention to when you're dealing with problems that are defined like this, where you are in the less than, instead of going up and down and forward, you kind of want to do a double negative and go up and down and backwards. Double negative, I made this a negative and a negative, so it's still a positive 1/2. That means we're going down and backwards. It's kind of easier to see than to describe, I think. Okay, the other one is a little bit more straightforward. Let's plot our second line. What is our coordinate point here when x is negative 2? Let's sub in a negative 2. All right, at negative 2, our graph is at positive 2. We want to have a closed-in dot because this has the or equal to the line underneath it. And now I'm going to use my slope, rise over run, for this second equation. It's negative 3 over 2, so that means we're going to go down 3 and forward 2. 1, 2, 3, 1, 2 to get my second point. I can keep counting if that helps. Let's do one last example, one where you have 3 equations. All right, for all x values less than negative 1, we are just the horizontal line at positive 1. So it's less than or equal to, so I need a closed-in dot. Okay, from -1 to +1, this is the line -3x. There's nothing added here, so my y-intercept is 0. So from 0, I just need to find my slope. I can write this as a fraction, so I'm going to go down 3 and forward 1. So from my y-intercept, 1, 2, 3, forward 1. Close dot. And I can do a double negative here, or switch the negative and make this, which means up 3 and back 1. 1, 2, 3, back 1 with an open circle for my middle line. At x equals 1, we are going to be the horizontal line 4. And it has an open circle for an endpoint and just continues on.